The biggest piles of sulfate waste for us are for in the US are in Florida because that's where the fertilizer industry is. And actually the two highest points in Florida are phosphogypsum mounds. They're sulfate waste mounds. Most good climate tech solutions aren't necessarily simple. My advice would be one, find the right VC that understands the space and what you're doing. One of the hesitations of why people are, well, why do we need to remove CO2 from the atmosphere is they don't.
Welcome back to Clean Techies, a podcast where we interview the leading climate tech entrepreneurs around the world and distill their lessons to share them here with you so you can benefit from their experience. I'm Silas Manor, and today I'm your host. For written analysis and in-depth show notes of each episode, be sure to subscribe on our Substack at cleantechies.substack.com. All right, let's get into it. Today, I am speaking with Owen Cadwalader, the COO of Travertine, a Boulder, Colorado-based climate startup with a 3-in-1 technology. What I mean by that is they have carbon capture. They also produce sulfuric acid and green hydrogen. And while they are a little bit of a newer name to the space, they are quickly approaching deployment of their first demo plant just outside of Rochester, New York. I believe, if I'm not mistaken, from memory, that'll be going live next year sometime, 2025. And that will produce over 100 tons of sulfuric acid per year. So, pretty impressive for a relatively new startup. In case you don't know, sulfuric acid is a byproduct of many different processes, but especially the production of fertilizer, mining of critical minerals, and the production of specialty chemicals. So in other words, it's something that touches the kind of the things that we all benefit on a daily basis from. So, it's a quite important thing if we'd like to keep all of our modern day nice things. And there are places where this waste is actually just piling up, causing toxic runoff, and it's also just a big eyesore. I made a little bit of a laugh about it in the episode, but in Florida, apparently the highest point of Florida is kind of this landfill of just this byproduct of sulfuric acid. So this also, just as kind of a disclaimer, this episode is perhaps the most dense episode we've ever covered because thankfully Owen is extremely no nonsense type of guy who packs a lot of value into what he says. Not a lot of filler words, unlike me sometimes, but it is a really good conversation. A couple of the things we discuss in today's conversation are, of course, his story of joining Travertine and the story of Travertine itself. We obviously go into the technology and break down how their business model works. Perhaps most importantly, he shares how they utilize effectively a 3 revenue stream model to help them win. It gives them a lot more flexibility to kind of have different ways of succeeding. They don't have to have, for example, carbon credits don't have to be in vogue at the time for them still to win. It's just a benefit to them. So it's really super interesting on that point that a lot of founders can take note from. He shares a lot about that. And then there was quite a lot of parts of the show where I basically treated him as a hypothetical advisor to the Trump campaign, or to the Trump administration, I should say, on how they could support climate technologies while also winning in the kind of industrial Cold War against China. So a little bit of an interesting take there. He's got some really, really fascinating perspectives. I think you're going to like it. The full conversation is almost an hour long. To get that, you will need to become a paid subscriber on Substack if you are not already. The free version covers roughly half of that conversation. And again, it is very dense. I hope you're going to enjoy it. In fact, I know you're going to enjoy it. With that, let's get into the conversation with Owen. All right. Welcome to the pod, Owen. How's it going today?
It's good. Yeah. Beautiful day in Boulder, Colorado.
I wish I could say the same, but winter has begun to set in Wisconsin, and it's kind of that hail/rain/snow type of year. So I don't go outside as frequently as possible. I stay inside.
It sounds like you should move.
I will at some point, just here for the time being. But anyways, man, I guess let's get started. Tell us, kind of to start us off, who is one kind of climate tech OG, or as we like to call them, clean techie, that you would love to have dinner with, and why?
Yeah, well, I did start in this sector when it was called clean tech. So, but I do like the climate tech rebrand. I think it would be Jennifer Holmgren, who's the longtime CEO of LanzaTech. That was a clean tech 1.0 company, still around today, turning CO2 into fuels. And the reason is she's seen a lot, and they've scaled up chemical plants, which is really important and very relevant to what we're doing at Travertine. The other thing that I just want to highlight with Clean Tech 1.0 is that everybody thinks of it as kind of a failure, and it really wasn't at all from a venture perspective. Kleiner Perkins showed that they invested about $1 billion and turned that into $3 billion. So not bad from a total venture return perspective, it just took longer than software companies, which is not not surprising.
Yeah, exactly. No, I think those are really good notes. I'm a big fan of LanzaTech. We need to get them on the pod at some point. It's been really exciting watching their kind of. I guess they're like a sister company, a Lanza Jet, I think, with some of their
Yeah.
recent plans and scale up. It's really exciting to see actual jobs being created and real scale being achieved. So
And it's hard to go from the lab all the way to commercial chemical plant.
exactly. Yeah. It's not easy competing with the big ones, right? But I guess tell us a little bit more about your background and kind of your personal journey into climate and entrepreneurship generally.
Sure. Yeah, I guess I'll start in college. I was a geology major in college, and at at that point, I got really interested in the particular area of geology and earth sciences where humans impact the earth and the earth impacts humans. And so, when I was figuring out what to do post masters, there wasn't a whole lot of options. The most interesting one at the time was environmental consulting or environmental engineering, where I was investigating contaminated sites and then designing and implementing remedies to clean up those contaminated sites. And from a technology and a science and engineering perspective, it was really interesting, but it was really frustrating because we were kind of at the end of the line. Industries had already made something, made their money, and made a whole lot of pollution and left it on the earth. And we had to decades later come back and clean it up. It's also consulting's not a very inspiring business model because it's just brains by the hour, and you scale that business by adding more people. So anyway, there was a group of people in the company that were working on a new technology. It was kind of the early stage of Internet of Things, and we were remotely monitoring and controlling different sites. And the niche we found was in stormwater management. And so it was take a civil infrastructure, a pond that's meant to capture stormwater, and lower the level of the pond based on forecasted rain. And so you effectively, with technology, increase the effective area of a piece of civil infrastructure and can reduce flooding, reduce erosion, improve water quality. And so we kind of built a product around this and then spun it out of the consulting firm, raised venture capital, formed a new company. And that was my first taste of entrepreneurship. And that company is still around today. And so anyway, that had run its course for me, and I moved to another early stage company in air purification, helped them grow the B2B and HVAC side of the business, worked in renewable energy for a little bit, and now at Travertine.
Yeah, that's awesome, man. That's a really cool journey. I think I would be curious to ask more questions about the IoT device company in the stormwater space. I feel like there's some interesting things, but we'll have to take that for another time. I don't think we have
Yeah, you
scope
should
for
get
that
them on the
today.
podcast. Alex Bettig from Opti would be a great person to get on your pod.
We'll definitely have to do that. I'll have my producer take note of that. Okay, so that's really great. So I guess then that brings us to Travertine. Tell us the story behind that. How did you end up kind of working at Travertine and joining in the very early days?
Yeah, it actually starts back in the Dartmouth geology program. So Laura Lammers and I were friends in college. We went through the same program, the same geology program in college. And she took the academic route, blew through very rapidly a PhD and a postdoc, and became a professor at UC Berkeley and an expert in carbonate mineralization. And I kind of took the more applied route through environmental engineering and then entrepreneurship and startups and bringing technologies from lab to market. And the other piece of the story is that in when Laura was at Berkeley, she had a joint appointment at Lawrence Berkeley National Lab, and she was part of a group looking at lithium extraction in the US. And she was talking with the CEO of a lithium company and about how they're extracting lithium. It's lithium from clay stones. And so the extraction methodology is basically you use sulfuric acid to extract it. And so to create the sulfuric acid, you start with elemental sulfur. So they were trucking in elemental sulfur. They had to do a lot of road improvements to truck in the elemental sulfur. And so Laura, as a geologist, is saying, well, there's a lot of sulfate in the desert. Can we use that? And that combined with her long time thinking about how do we actually do carbon dioxide removal at scale at an economical perspective, she kind of combined those two influences and developed this electrochemical technology for recycling acid and doing end-to-end carbon dioxide removal. So she did a proof of concept in her lab at UC Berkeley, and we were catching up. And she said, this technology looks like it's something that could actually scale and do carbon dioxide removal at scale and be economical. And I said, well, if you are thinking of taking it out of the university and making a company, I'd love to help. And so here we are about 2.5 years later, and we've got 24 people, and we're in the middle of engineering for a demo plant that's going in the field. So it's pretty exciting.
You know that feeling when you meet someone who shares your vision for the future? It just clicks, like two peas in a pod. Well, that's exactly how we felt when we met Goodwin, who we are proud to have as our sponsor.
Being the first major law firm to set up a climate-specific startup and venture practice makes them exactly the kind of partner we are excited to work with. They realize that there are a plethora of challenges to building climate tech startups, and that's why they have built an entire suite of resources for founders, investors, and entrepreneurs in the space. They even offer several tailored pricing methods. And guess what? It doesn't matter where you are listening to this. Goodwin is a global law firm that you can trust to be your partner through it all, from incorporation to exit. They've got you covered.
Go to goodwinlaw.com and tell them Clean Techie sent you to get exclusive access to startup resources. All right, back to the show.
It does sound very exciting. I'm kind of curious. I mean, you had a lot of good experience prior to ending up joining Travertine. So, like, was it pretty obvious to you that this is definitely something I want to get behind, or was there any hesitation you had there? Like, what made you so confident to make that leap?
That's a good question. I'd say the first thing is that if there's anybody in the world that I know or have met that can think holistically about the carbon cycle and about how we can actually scale carbon dioxide removal, it's Laura. She's one of the smartest people I've ever met, and is an incredibly holistic thinker about things, and not very. She's not a narrow thinker, and so that was really a first thing of saying, if Laura thinks this makes sense, I think it's probably something that makes sense. And also, having known her for 20 years, I knew that we could work together really well. I think the other thing is that for me, looking technologies to do carbon dioxide removal, ideally they have other ancillary benefits for the environment, and can have a business that's wrapped around them that isn't solely reliant on the carbon dioxide removal market, because that's very nascent and we don't really know where that's going to go. And so I think those two things combined, the fact that we have other revenue streams other than just carbon dioxide removal, and confidence in Laura, and known ability to work together, were the three things that said, yeah, I want to spend time doing this.
Yeah, that's really interesting. I like the point about having multiple, I guess you could say, business lines or ways to make money. I think this is something often overlooked. Some people get really dogmatic about carbon capture and carbon removal, and then they kind of tend to make maybe silly startup decisions, if you will. So I appreciate that perspective. And I guess before we get into the technology itself and how it all works in particular, what is the overall vision or impact that you guys hope to have?
Yeah. So I think, just stepping back from that a little bit, I really believe personally that the best way to make environmental impact is to align positive environmental impact with positive business impact. And so you make sure that those two things are inherently linked, and then you focus on making a really great business and scaling your business. For Travertine specifically, the ultimate goal is for us to replace sulfur burners with our carbon negative and minimal waste process for producing and recycling acid, and for taking carbon out of the atmosphere. So that's our ultimate goal. If we look back 20 years from now, and we've replaced a good number of the sulfur burners in the world, we've been very successful.
And real quickly, what do you have an idea of roughly, like, if you replaced all of those sulfur burners, what the kind of mitigation would be from a carbon perspective? Do you have those numbers?
Well, no, not off the top of my head. Sulfur burners themselves are not carbon emitting, and so it wouldn't be about mitigating carbon emissions from sulfur burning. It would be about mitigating a huge amount of waste
Mm,
and being able to do carbon dioxide removal.
got it. Okay, very
So,
cool. So
but it would be on the order of hundreds of millions of tons a
okay,
year.
yeah. So a huge impact, right? That's good to hear.
Yeah.
So I guess let's then go from here. Let's get into the technology itself. So just kind of remember, keep in mind, a lot of us are not scientists. So for in really simple terms, explain to us, what is your technology and what is the problem you're solving?
Yeah, so we recycle sulfuric acid, and that eliminates a byproduct or a waste product from both certain types of mining extraction, certain types of fertilizer production, and other specialty chemical production. And the same chemical process that recycles acid, our travertine process, also takes takes carbon directly from the air and makes a solid mineral out of it that you can quantify and that is permanent. And so essentially it's a circular chemical plant for enabling the production of fertilizer, the production of food products, and the production of metals that we need for the energy transition, like lithium and nickel.
Climate tech founders are taking on a huge challenge. Not only do they need to know how to build a startup, but they also need to deal with hardware, have a strong handle on climate policy, know how to fundraise from diverse investor types. It's a lot.
That's why we made Clean Techies, the #1 podcast for climate tech entrepreneurs. In addition to our jobs, we devote 20 hours a week to producing this podcast for you. This way you can learn from the people who have walked the path before you, learn from their mistakes, and gain insights on navigating this complex journey. If this mission resonates with you, we are asking for your help. It takes a lot of effort and it's not free.
If you are already a subscriber and want to help, start supporting us today by going to Substack and clicking Upgrade to Paid. Thanks for helping all the climate tech entrepreneurs like you. So just to make sure I've got this right, there is kind of a waste product through certain mining processes that's tends to get kind of tossed into the environment, or they have to pay to dispose of it, I'm assuming, but you're able to help capture that and then turn it into additional products through your, process that you're adding, carbon capture to. Is that correct?
Yeah, that's right. So sulfuric acid is at the heart of it, and the way that you extract the element that you care about from a primary ore, you do a number of things, but one of the main things you do is you digest it with sulfuric acid. And what ends up is that you get what you care about. Let's take lithium, for example, or phosphorus for making fertilizer. You get that critical element from the ore, but you end up with a huge amount of waste, a huge amount of sulfate waste. And generally what happens to that today is it just gets landfilled in a specific landfill near the plant. And so what we can do is either recycle that byproduct and back into sulfuric acid to be used, or we can actually go end to end and produce that end product.
Interesting. Okay. Yeah, I think this would be a good point to plug. If people haven't already heard, I'd recommend going checking out our past episode with Liz Dennett from Endolith. There's some they're also in the mining space. There's some similarities here. Let's talk about why is this important? Like why is solving this problem important aside from reducing carbon emissions?
Yeah, so obviously reducing carbon emissions is a big part of it. The other big part, and if you talk to people in the industry, the biggest part is managing the waste. And so nobody wants to be producing this huge amount of sulfate waste or byproduct. And everybody wants to figure out a better way to do this. And this is true across the globe. So the biggest piles of sulfate waste for us are in the US are in Florida, because that's where the fertilizer industry is. And actually the two highest points in Florida are phosphogypsum mounds. They're sulfate waste mounds. Yeah, it's kind of a crazy.
I only laugh
400
because
feet high.
Yeah, I only laugh because Florida is so flat. I always make fun of. I lived in Florida for 2 months,
sure.
and I just always joked about how flat it was.
It is flat, but it's still 400, 500 foot high pile, and so it's a big problem in the U.S. It's a big problem in North Africa. It's a problem in throughout the world, and so that's eliminating waste is the primary driver that customers and partners are interested in. And the carbon dioxide removal, which is also a waste in and of itself, is another part of it, but a lesser extent than the sulfate waste.
Is there any particular, I guess, studies or examples you can give, like the negative effects of just having that waste in those piles? Like has it caused any particular events or climate events of any sort?
Sure. Yeah. Not any climate events, but it is a environmental potential contaminant. And so the EPA regulates phosphogypsum, which is the waste that comes out of phosphate fertilizer production. They regulate it. You have to stack it. You have to hydraulically contain it. If you go and look up a phosphogypsum in Florida, you'll see a number of issues where there's been sinkholes or there's been contamination of local waterways. And so it's a potential environmental contaminant beyond just being physically large as well.
Yeah. I could also imagine that there's probably, I don't know how you model this out, but there's probably huge costs of if this does end up causing some kind of issue, like the local city governments or whatever probably have huge costs to remediate it.
Yeah, 100%. It's also a big cost and a big liability for these major corporations.
Yeah. Oh, that's true. I guess. Yeah. Yeah. That makes a lot of sense. So, okay, then let's talk about who exactly are your customers?
Yeah, so our customers are anybody that is using sulfuric acid to produce an end product, or potentially the consumers of those end products themselves. So what does that look like? That looks like mining companies that are mining lithium from claystones, nickel from nickel laterites. And the biggest portion and the biggest use, about 55-60% of sulfuric acid use is used for phosphate mining. So phosphate mining to produce phosphoric acid to produce fertilizer that goes directly on farmers' fields.
Okay, and then so what are these customers currently doing as like a solution to this problem?
Well, there isn't really a solution to this problem. What they're currently doing is using sulfuric acid to digest primary ores and producing this sulfate product, the phosphogypsum or sulfate product. And that's just landfilled currently
Mm,
today. The other thing I'll add is that so it's not only the fertilizer industry in phosphates. There's another part of the industry for purified phosphoric acid that goes into food. It's what is in Coca-Cola and PepsiCo and Pepsi. It's also the P and P batteries, and so it's beyond just fertilizer and mining. It's also to make electric vehicles and also for food products.
got it. So when you say there's no solution, like do they actually have to do they typically pay for those for putting it in the landfill?
There is a cost associated with managing the landfill, yeah, and it's not just sort of your municipal landfill. It's a dedicated stack for this product for the phosphogypsum product.
Is there, I didn't have this in the kind of prep doc, but is there a particular ROI for these companies aside from mitigating the future, like, financial risk of having to do remediation? Is there some kind of immediate return for them to recycle
It's
it?
it's really hard to put a dollar per ton value on it because it's a long-term liability. It's not on the P&L.
Got it. Okay, that makes sense. And then I guess just to clarify for people, what are the like how are your revenue streams? I think this is a really important part of the technology and why you joined. So explain to us the revenue streams.
Yeah, so we have a mix of revenue streams, and what it is either sulfuric acid or a product that's produced using sulfuric acid. So that could be lithium, could be nickel, it could be phosphoric acid. So that's the primary revenue stream. And then the other product that we produce is calcium carbonate. And calcium carbonate, it can be used as a supplementary cementatious material into cement. And so one of our biggest investors is actually Holcim, which is a Swiss cement company, and they're very interested in using the calcium carbonate in as a supplementary cementatious material. And the third revenue stream is carbon removal credits. And so that's the smaller portion of our revenue stream.
And I guess the thing I'm kind of curious if you could just maybe break this down from not from Travertine perspective specifically, but for other entrepreneurs in climate, like why is it so important to have multiple revenue streams and maybe in particular for this space, for the chemical space? Why does that matter?
Well, I think it makes your business more resilient because if you're selling products that have changes in pricing or changes in regulation that changes what their pricing are or changes in demand, then you have other revenue streams to rely on. I also think there isn't a chemical plant in existence that only produces one product. And so it's just kind of how the chemical industry runs uh, and operates. But it's not a simple thing that VCs tend to like, but it is, but I think it creates, and I think most people would agree, it ultimately creates a much more robust business.
This is a really interesting point. So let's break that down a little bit. So you said VCs don't like, let's call it more complex kind of revenue models or business models in general. Can you just talk a little bit about that? And then hopefully founders will understand the importance of thinking about more than just one product line. Because I think a lot of these deep tech founders like, oh, we've got the silver bullet for one thing, therefore we're going to make money. But can you
Yeah.
break this down and how you had to pitch to VCs?
Yeah. Well, VCs tend to like simple, and they tend to like simple for a couple of reasons because then you're just focusing on one type of risk, whether it's technology risk or market risk, and also as a new company, it's hard to manage either a process that's complex or more than one thing at a time. So VCs like simple, and I understand that, but one of the challenges is that most robust and most good climate tech solutions aren't necessarily simple, and so that's a big challenge. And so I guess my advice would be one, find the right VC that understands the space and understands what you're doing. Do your best to make the complex simple, and then show customer demand. Because if you show customer demand, it means there's a market for what you are selling, and it means that that will drive growth and drive the company forward, even if it is something that's challenging to do.
Yeah, that's really helpful. And then I guess last thing, and just kind of to recap the tech, and we can move into some trends and topics here, is where are you guys at today in terms of total scale?
Yeah, so we're in the middle of engineering a demo plant that'll be over 100 tons a year of sulfuric acid that'll go into the ground at a site with a partner in outside of Rochester, New York, in the middle of next year. So it's a pretty exciting time. It'll be our first real field deployment of the technology, and we'll be taking gypsum, a legacy stack of mined gypsum, and producing sulfuric acid for Sabin Metals Corporation. And Sabin is a wonderful company that recycles precious metals, and they've been around for over 100 years, and they're an expert in precious metals recycling. So it's a pretty cool circular story from using old mined waste in our new process to remove carbon dioxide, produce sulfuric acid, and then ultimately have that sulfuric acid used in recycling of precious metals.
Well, one thing I didn't, I guess, plan to ask, but I'd be curious if you said you were building a plant. So is there any way that eventually this can be turned into a modular technology, or does it always have to be on a project by project basis?
Yeah. So people love talking about modular technologies, and there are advantages and disadvantages to modular technologies. The advantage is you can get really good at building that one thing, and you can reduce your unit cost to produce that one thing. The bad thing is that as you scale, you don't get economies of scale on the actual overall project. So there are some disadvantages and advantages of modular technologies. Our technology, parts of it are modular. And so one of the main unit operations in our technology is electrolysis and electrolyzer. And that is a very modular technology.
Mm-hmm.
Once you get one commercial scale cell, you add additional cells or additional banks of cells. So that unit is modular. The direct air capture portion of our technology, we do caustic direct air capture, and that is also a modular unit. But the balance of plant, which is mainly tanks and pumps and ion exchange and other types of equipment, that's not necessarily modular, nor does it make sense for that to be modular, because as you scale, you don't want to have 500 small tanks. You want a couple of big tanks, right? And
Yeah.
that's cheaper. And so I view our technology as a good blend of both modular and stick built and scalable technologies. And I really think that for many technologies that need to achieve a large scale is a good blend, not just saying, oh, hey, we can build this in a shipping container and then build a lot of shipping
Mm-hmm.
containers. That actually doesn't work
Yeah.
from an economics perspective for most technologies.
Yeah, that's a really interesting point. I guess I haven't really dug into this before. The reason I asked it was we had Skytree on recently, and there he was really bullish on saying that you need to build on a modular method for iteration cycles. But I think having that kind of combination is something, at least if you're going to build projects, if you have to build project basis, at least have
Yeah.
portions of it that you can, achieve scale with,
It depends what your business is and depends what you're doing. And it doesn't, I think it's trying to fit everything into one box doesn't make sense.
Mm-hmm. Yeah. Awesome. So let's shift gears a little bit. So I want to talk a little bit about pricing. You kind of alluded to it with having multiple product lines, but also just your go-to-market in general. A lot of people, they're thinking that they're going to compete at scale, commodity type of product. Can you just talk about your guys' path to going to market and having like a high value product that you can compete with versus just trying to compete purely on a commodity basis, and just maybe open this up for other people in the space who are working on related technologies?
Sure. Well, competing with incumbent technologies producing a commodity is incredibly challenging, because you're almost never going to compete on price with that commodity, at least on your first plant or your first several plants, right? Because that technology has been optimized for decades, and you are starting at a smaller scale, and generally there are economies of scale, and you can't immediately build something as big as a company building that's already producing commodities. So it's really, really challenging, at least at first, to compete with commodity chemicals or anything that is a commodity. And so if you move to a higher value product, or you take over more of the value chain, that gives you more margin to work with for your first several facilities, for your first several plants. And then as you scale and as you cost down your technology and as you learn more about distribution and supply chain and everything, that you can actually you can then move towards commodity. And depending on what your technology is, you may be able to eventually be cheaper than that commodity. But it's very, very challenging to start and say, I'm going to go take over the steel market, for example. And I'd say, the classic example, OG climate tech of this is Tesla, right? They started out with a $100,000 plus Roadster, then the Model X, then the Model 3. They were going to do a $25,000 car, but I guess then they kind of went off the deep end with the Cybertruck. So, but yeah,
I think that they realized they needed to make some high margin type of vehicle. I think, if I'm not mistaken, trucks are in the general automotive industry. Trucks are what really make the big bucks. So maybe
yeah,
that's what they had to do.
yeah.
But that is a good point. I think this is something a lot of people, a lot of founders in climate tend to get wrong, is they don't recognize that you have to have a beachhead market where you can compete, and then over time you can scale up. Do you think there are, like, if somebody's thinking of an idea today and they can't find a way to compete on, like a high value product initially, is it even worth pursuing that company, that opportunity, if there's big incumbents?
Well, I think you got to look at the techno-economic analysis, and you got to be real about your techno-economic analysis, and you got to go talk to people in the industry and see if it's feasible. There certainly could be technologies out there that can produce at a small scale in your first plant, lower cost than commodities, but you really have to pressure test that.
Yeah, I can imagine you really have to like think it through, because if it is so easy to compete with a new technology on the commodity basis right away, I'm assuming the big incumbents would have a very high incentive to just gobble it up really quickly, your technology, right? If it is that truly that simple.
Certainly, yeah, yeah.
Yeah, so let's go into, let's talk a little bit about politics. So a lot of people are very concerned about Trump and the White House changing to kind of let's call it a less than friendly environment to climate. And many people have heard different takes about what it will mean for the sector. But let's talk about what it specifically means for Travertine. And I think this is interesting because you guys are playing across carbon capture, waste mitigation, and chemical production. So kind of what impact do you think overall Trump will have for your business?
Yeah, it's a question that's on everybody's minds that are in the climate tech space right now. For us, we're also enabling onshoring of critical element production, which is paramount for national defense and which is a priority of the Republican Party and of Trump. We're also so I think that we have that really strong thing going for us as a company. We're also reducing waste, we're reducing environmental harm, and we're onshoring production and manufacturing. And those are incentives that I think cross party lines and cross even ideologies within parties. The fact that our revenue stack is not 100% dependent on CDR, and that in fact in the higher value products, the higher value applications, CDR is a minority part of our revenue stack. That is also a really strong benefit for us as a business. And the way that we look at it is, on the long term, we're building a strong business that's resilient to whatever party is in the White House. And I think that anybody that is in the climate tech space, it's not going to get solved in 2 years or 4 years or even 8 years. And so you have to think on the long term, and you have to build a business that is going to be resilient to different changes in the market, in policy, in administrations, et cetera.
I do think this is super important. And again, a lot of people are very upset about the outcome of the election specifically for climate. But, my silver lining take is, like, hopefully people will learn to be resilient regardless of who is in the White House, because if we truly care about making an impact, you can't just have it one way, right? Because there is going to be cycles and it's going to flip back and forth, every so often. So you have to be willing to build.
We need resources from the earth to live our life. The safest and the least environmentally harmful place in the world to do that is the US. That lack of consistency is bad overall for industry and businesses that want to build in the US. If your goal is to solve a problem for a customer or solve a problem in the environment and for a customer, then you're going to want to do that with the best technology available. It's logical for us now. It's like you pay for trash, right? You pay to take out the trash. It doesn't, you can't just throw your trash on the ground. But it's not how we think of CO2. Most people don't focus on the business aspect early enough and figuring out what that business is. If you want to disrupt an industry, understand what that industry is doing first.
All right, everybody. Thanks for sticking around this long. Unfortunately, this is the end of the free version of the episode. As you may have noticed, we are tracking at a very high value per minute rate with this episode. To get the rest of that value, where we discuss the temperature of the CDR space, how founders need to not be precious with their technology if they do care about solving climate change, how they funded their first project, and their overall funding journey, what he'd tell Trump to do with the LPO. Ooh, interesting. A paradigm shifting perspective on how to treat CO2 like the other wastes that we have. And finally, we wrap with some of his takes on the broader trends, and then, of course, our rapid fire questions. If you'd like to get the full version of this episode, you can become a paid subscriber by going to cleantechies.substack.com/subscribe and choose any paid tier subscription. You will get access to the full show, to this full show, and all future episodes, the full uninterrupted, no ads version. And if you don't want to spend the money, but you really want to hear the rest of this episode, which again, it is quite dense, so it's very good bang for your buck, you can redeem your one-time trial of Clean Techies Pro by going to the Substack app and just redeeming it. We always allow people to do that. So especially if Owen's your friend and you want to support his episode, I'd recommend giving it a listen and sending him some feedback. Again, this is really helpful if you become a paid subscriber. It helps us to keep this show going. One other perk that we do offer to all paid subscribers is a kind of a back channel WhatsApp chat where oftentimes we're giving people heads up on who we're going to interview. We get their feedback on what questions to ask them, and it's just kind of nice. We get to chat with them in the background, so we appreciate our supporters doing this and keeping the show going. So if you would like to become a paid subscriber, you know how to do it. I've told you many times, so we'll leave it with you and see you next time.